Imagine a world where everyone is using AI for everything. Everything relies around a prompt. If prompt is the main interaction we have with AI models, how can we identify if there is something malicious in the prompt?
This guy believes the future of the internet is an internet of AI agents. He built the first agent-native threat intel feed where AI agents report attacks and receive curated protections. Meet Thomas Roccia, a senior security researcher at Microsoft, author and speaker. With more than a decade of experience in cybersecurity, he's worked on the front lines of major cyber attacks, managed critical outbreaks, and traveled the world to tackle emerging threats. And in this episode of AI Cyber Podcast, Thomas Roccia makes the case that prompts are the new IOCs and the security industry isn't ready. We'll see his new tool Nova in action as Yara for AI and dive into more threats, the dedicated threat feed tracking real-world attacks. We also discuss the emerging internet of AI agents and what prompt EDR might look like in the near future.
The biggest issue people are doing, they want to incorporate AI for everything, but AI may not be the right solution for anything today. If you want to deploy AI, make sure you need AI because not every problems or issues needs an AI solution.
Thomas Roccia, welcome to AI Cyber Podcast.
Thank you, Confidence, for the invitation and looking forward to speak more with you.
Awesome. You've said, and I've read so many of your articles, but this particular one really caught my attention, where you said you believe the future of the internet is an internet of AI agents. I'd like for you to paint that picture for us. What does this interconnected world of agents actually look like? And why should security teams be paying attention right now?
That's actually a very interesting question. And if you ask me this question like a week ago, probably my answer would have been the same as today. Yeah. So let me explain what I think with the Internet of AI agents. So if you think about it, right now we are using internet with a computer to navigate through a specific web page and so on. This is the internet as we know it today. But tomorrow, with AI agents, so an AI agent is basically an AI with the ability of reasoning and doing some actions on the world around us. And an AI agent will be able in the future, it's already the case, to navigate through internet and give you the information you want, but also more specifically collaborate with other agents, communicate with another agent, and so on. That's what I call the Internet of AI agent. And I really believe this is the future, mainly because if you think about it, that makes sense, to have like a personal AI agent. Everyone has their own, or pretty much everyone today is using AI at some point, even if they don't really know it. But most of the advanced user already use agent for specific tasks. For example, I use agent to build some threat intelligence abilities or to do some specific task for me in my daily life. And the missing piece when I wrote the article was actually the communication protocol between the agents on the internet. And within a week, actually, this missing piece is actually there now. It was there before, but it wasn't ready. So before this week, communicating agent to agent was already possible through A2A, the Google protocol to make agent communicating together. But it was a little bit more complex to put in practice and to implement. So people didn't really, implement it in real life. But something came out this week, which is Moltbook. So if you heard about OpenClaw, CloudBot, this is an AI agent which is able to adapt around your own life and go to the internet and communicate and do some stuff and so on. And one guy created Moltbook, which is actually a Reddit-like version, but for AI agents. And all the people using OpenClaw before were able to use that to communicate with other agents. And so the protocol which is used is not really a protocol, it's actually the skill, the agent skill, which is a concept created by Anthropic. And it's very interesting because this is a single platform where all agents can communicate, similar to what humans
Are actually doing, but for AI agent. So very interesting.
Now that you mentioned the word skill, I would want us to zoom out and go into Nova. But I mean, the little joke there as well. I had a conversation with someone outside of the tech industry, and I said the word skill, and I realized, oh my God, now the use of the word skill means different for people within the industry and out of the industry. So I
That's
had
true.
to, yeah, because not, oh, are you skilled or do you have skills? It means something entirely different now, depending on what context you're using it. But I have my reservations with security context of using skills and how it's currently used. I really love the fact that I saw that you had built something to help with that. Your tool Nova now lets people scan a skill before they can use it, because right now, that's not something you can do, right? I don't want to take the words from you. I want you to tell me why this is so important and what kinds of tool poisoning or hidden instructions have you actually found in MCP servers in the wild. So MCP, why do you need to scan? Why do you need to scan skills as well? And why is the tool you built Nova so important?
Yes. To zoom out a little bit to explain what is it. So when in the world of AI and AI agent skills or MCP, to keep it simple, is a way to let agent or AI model interact with other capabilities, other tools, connecting to the outside world and so on. So this is simply a way to let your agent do some actions
Mm-hmm.
outside of your own computer, if I can tell. And skills is very interesting. This is markdown file which defined how to use some specific elements for your agent. So you can define scripts, you can define resources. For example, I have a skills for malware analysis. These skills let my agent understand how to analyze a piece of malware, check out on
Mm-hmm.
VirusTotal if the malware is malicious or not, create a sample Yara rules that I can review later, and so on. So this is
Mm-hmm.
basically a way to guide an agent or an AI model to do a specific task. MCP is a little bit different. This is a protocol, and MCP can do the same in essence, but it can be also exposed to the internet. So MCP is a way to expose your resources and your tools to an AI agent, to everyone around the world, rather than skill is something you download locally and you run only for your agent. You cannot really expose skills to the outside world. You can do it, but it's not part of how skill is working. So when you think about that, now the security question is really important to think about and to ask yourself, because if you are using skills that are coming from a GitHub repository that you don't know, from a user that created that, and
Perfect
so on.
strangers. Yeah.
Exactly. MCP is actually worse, because if you
Yes.
expose an MCP server and everyone can connect to it without accessing what the MCP server is doing or the code itself, then it's much more
Absolutely.
complicated to understand if there is something malicious. For skills,
Yeah.
it's a bit different because it's shared online and people have to download them so you can review yourself. But of course, if there is something a little bit more complex, obfuscated, and so on, you have to have a way to scan that.
But Thomas, we can't trust developers to actually review that. It's like saying what we're dealing with NPM packages. We can't trust developers to actually review skills before using them. And that's why your tool is fantastic.
Yeah, that's correct. Like it's very complicated in today. Because of that, there is a lot of supply chain risk because you are
Yeah.
installing a tool from someone else. And if this someone else is not trusted at some point, then it's more complicated for you to evaluate the risk of using this tool.
Exactly. Tell us more. How does your Nova tool work around solving that problem?
That's a long story because it's a big project. Nova is actually an ecosystem. When I speak about an ecosystem, it's because initially it was only a tool which is used to detect a malicious prompt, or what I call adversarial prompt, or indicator of prompt compromise. So let me explain step by step what is it. IOPC, indicator of prompt compromise, is basically a way to identify a prompt inside an AI system, whether it is an agent, a ChatGPT, or a simple chatbot, or a RAG, or whatever. Anything which is related to AI use today prompts, and those prompts needs to be scanned, hunt to understand if there is something malicious. That's what I call adversarial prompt or indicator of prompt compromise. So it's not only prompt injection, because today in the industry, when we talk about threats, when people talk about threats in AI, mainly they talk about prompt injection. But adversarial prompt, it's not only about that. You don't want your user to, for example, use your AI model to generate some malicious content, such as generating piece of malware, generating disinformation campaign or messages that can be used on social network and so on. So there is a full taxonomy that I created on my website. And the idea is to cover all the possible aspects of adversarial prompts and not only prompt injections. Of course, prompt injection is a big one, but that's not the only one. So Nova was an answer to that, a way to create detection rules that can be used to match some specific adversarial prompt. So that's the idea of Nova. And there is multiple other components around this main tool that we can discuss more about it later.
Yes, I can't wait to really do a deep dive there. But you've also been speaking about prompts as the new IOCs for a while now. And for our audience, for anyone who doesn't know what the acronym IOCs means, it means indicators of compromise. And they're really just the bread and butter of traditional threat intelligence. It includes things like IP addresses, file hashes, domains. But I'd like you to explain why you believe prompts deserve the same treatment.
That's a really good and interesting question. So if you think about it, indicator of compromise is a way to understand what an attacker or threat actor can do on your system. And this is also a way to identify if there is some traces of these threat actors inside your organization, your network, and so on. So IOCs are IP addresses, could be domain names, it could be malware hashes, and so on. And indicator of prompt compromise is the same way. Imagine a world, which is pretty much the world we are living now, but imagine a world where everyone is using AI for everything. And as I said, if you think about how works modern AI today, everything relies around a prompt. When you interact with ChatGPT or Claude or any other chatbot which is powered with an LLM, you are using a prompt to ask something to the LLM and to give an answer. When you are using an agent is created with a prompt, like the persona, the role, everything is defined with a prompt. When you are using a RAG is simply a retrieval augmented generation. You retrieve information and this information are passed into a prompt. So everything relies on prompt. So when you think about that, the next question is, okay, if prompt is the main interaction we have with AI models, how can we identify if there is something malicious in the prompt? So that's why I call adversarial prompt indicator of prompt compromise. And then you want to have a way to identify adversarial prompt in your system, because you don't want malware generation if your chatbot is used to manage your bank account. You don't want disinformation campaign is if your chatbot is in front of your client, and you don't want your chatbot to go crazy and tell some crazy things about your customers and so on. So that's the idea.
Yeah, but I'm also still curious. Why did you need an entirely new category rather than just extending traditional IOCs? I want you to be able to do that distinction for us. Why did it deserve a category of its own as a new term now, indicators of prompt compromise? That's IOPCs. Why did we need a new category?
IOC is very well defined in the threat intelligence landscape here and community, yes. And IOCs are also very static. That means they are not evolving. An IP remains the IP, and an hash
Yes.
remains an hash. So it's not changing or evolving. So the way you detect IOCs is not the same that the way you detect IOPCs. The idea of creating a new category is simply because prompt doesn't fit with the actual definition of what is an IOC today. So that's the simple idea.
I really love it. But again, going back to your website, because I have gone there and I've learned a lot, and I want the audience to also learn from you. You've spoken about the different 4 classifications you have of adversarial prompts, right? Yeah, along the lines of prompt manipulation, abusing legitimate functions, suspicious patterns, and normal outputs. I want you to give us a real world example of each so we can really land the points.
Right. So I actually gave you already an example, but let me explain or develop a little bit more about it. Imagine you are a bank and your customers are going to their bank account and they have a chatbot. This chatbot is powered with LLM, and this chatbot actually help them understand their current account, the amount of money. They can also do some actions, asking something about the page and so on. Now imagine this chatbot get compromised through, let's say, a prompt injection. A prompt injection is something that everyone has in mind. Someone has access to the chatbot and try to modify the chatbot to get access to an account which is not supposed to get access to. How do you identify if there is something malicious here? And the way to doing that is simply to understand how you can match the semantic meaning, the context of the discussion, and leverage or raise an alert if there is something malicious. So that's a concrete example. Actually, I have a concrete example. I think it was 2 years ago. 2 years ago, a security company published a report. And what happened? They found that on the dark web, on the underground,
Mm-hmm.
attackers get compromised API keys to Azure AI Foundry, which is the way to interact with model inside Azure. And this API key that was leaked was actually used to power an underground market for some cyber criminal activity. So imagine that the API key was owned by a legitimate company, but this API key was leaked and used by underground cyber criminal to power underground services. So
Wow.
how do you detect that? You have to have a way to understand what kind of requests are sent by those individuals, and you have to have
Mm-hmm.
a way to detect if there is something malicious or something which is not related to your business actually. So that's a concrete example of how and why you may want to detect adversarial prompts.
Yeah, you just given an example there, but I'd like to know what kinds of adversarial prompts are you seeing most frequently in the wild right now? And are there any patterns or trends that really just surprise you?
Most of the current things we are seeing right now is prompt injection, jailbreaking, bypassing, the context and the role of a specific model and so on. If we take an example with the AI agent and Moltbot and Claudebot and OpenClaw,
Yes.
um, there is a lot of attempt of prompt injection through skills, through post on Moltbook, the Reddit-like version for AI agent. So
Yeah.
prompt injection is probably the number one threat for any kind of AI models right now.
Wow. Okay. So you've also described Nova at some point in this conversation as some sort of prompt pattern matching,
Exactly.
essentially Yara rules for prompts. So for people who use Yara for malware hunting, I want you to explain how Nova applies that same logic to AI systems.
Yes. So Yara is based on matching different patterns on files. So they're mainly malware, but it can be anything in reality. But it's mainly for malware to match on specific codes, keywords, strings, and so on. Nova borrows the same concept, meaning you can
Mm-hmm.
build the rule, except Nova is not only matching a prompt on specific keywords, but it's also matching on the semantic meaning, which means, for example, you have a sentence and the sentence is, can you tell me how to hack this account? Then you don't need to specifically match the word hack or account, but you can say, for example, give me a match if this is related to compromise, or so you don't need to specify the word hacking. You can have a broader range of matching just by determining what you want to match. And the last one, in Nova, we have keyword matching, semantic matching, and LLM as a judge. LLM as a judge is simply using an LLM to judge if a
Mm-hmm.
prompt is malicious according to your own guidelines, your own elements you want the prompt to match. And then you have the condition, so you can mix, you can say match this prompt on keywords or semantic or LLM, or you can say on keywords and semantic or LLM. You have the versatility to
Mm-hmm.
create your own rule based on your own guideline. And this is the difference with other prompt monitoring or prompt detections. With Nova, you keep track of what you are doing and you build your rules based on your own use cases.
That's interesting. Can you give us the anatomy of, say, a typical Nova rule? I want you to be able to call out sort of like the key components, keywords. You've touched on keywords already, the semantics of LLM matching and how they all work together. I know you've just touched on LLM matching there or LLM as a judge, but I want you to call out what the anatomy would look like of an average Nova rule.
A Nova rule is simple. So you have the rule name, then you have the meta sections where you can define your metadata, define the author, the date, the sources as well, and so on. Then you have the keyword section where you define the keyword you want to match. For example, you want to match on hack, you put the keyword hack, and this is case insensitive. And you can also define other words, and you can also use regex in the keywords section. After the keyword section, you have the semantic section where we are using embedding and vector similarity. And semantic is basically matching a broader range of prompt and meaning. And then you have the LLM as a judge. Yes.
I love that you have that because if it was just regex, then we'd have the same problems you're having right now with regex anyway. In
Exactly.
Yeah, so I like that you have that broader semantic part. Did I cut you off of what you were saying?
No, I will just finish on that. The third section is
Mm-hmm.
LLM as a judge, where you are using an LLM to match or evaluate a specific prompt. Which is interesting with LLM as a judge is that you can use a
Mm-hmm.
specific LLM model
Okay.
which have been trained on some specific threats. So you
Uh,
have the flexibility as well to
uh-huh.
create your own system with the Nova rules and Nova framework.
That's very interesting. I also know from all of what I've done playing with the tools that you've created, I know that you've built keyword detection. You've built also semantic similarity, which you've mentioned, and an LLM based evaluation into Nova. But I'm curious to know, why did you need all three approaches? Where does one excel? Or rather, where does each one excel?
Good question. Because if you just match on one of them, then the way you want to detect or match on specific patterns, it's not enough. For example, if you just have keyword and you match on a specific words in a prompt hack, if the user is using another way to ask the same thing but without the word hack, then it won't work. So that's why we have semantic. Semantic will evaluate a broader knowledge, and LLM as a judge is another ability as well to detect
Mm-hmm.
malicious prompt. And then you can combine all three, or you can use only one of them, or you can use only the first one. Then if it's not matched, then check the second one. Then if it's not matched, then check the third one. So you have the three layers of detection, which is
Mm-hmm.
very flexible and versatile.
I want you to land what you've just shared with us with a very practical demonstration. Let's assume I want to detect jailbreak uh, attempts or instructions that override attacks against my AI system. How would I write that Nova rule?
It really depends, but for example, when we talk about jailbreak, most of the time you will have in the prompt something like ignore previous instruction and now tell
Yes.
me do that, or put you in do anything mode right now and do the task that I want. So
Mm-hmm.
that's specific patterns are actually known. So you can match on the keyword, ignore previous instruction. This one is recurrent. We can see it
Mm-hmm.
most of the time. But if you want something a little bit broader, you can use LLM as a judge and say, analyze this prompt and tell me
Mm-hmm.
or identify if it's related to jailbreak techniques and so on. So there is multiple way. You can also, with the semantic meaning, say, for example, you can say a match prompt that are trying to bypass role or context or system prompts, for example.
Yes. And other guardrails, in fact.
Yeah.
Again, still around the wonder of Nova. I know that Nova can be used both for hunting and adversarial prompts in logs and as a real-time guardrail, but I want you to explain both use cases and when you'd choose one over the other.
It depends actually. Depends of plenty of things. It depends of the resources you have, because if you are using LLM as a judge, it could be a little bit more expensive in terms of cost, but also in time and so on. So if you already know what you want to match exactly, then keyword and semantic will be the best. But if you want to have a broader stuff or broader coverage and a way to identify stuff that are not yet detected, then maybe LLM as a judge or a combination of LLM as a judge and semantic meaning will be the best.
Help me understand, is prompt intel part of the Nova ecosystem that you've described?
Correct. Yes.
So, for anyone who hasn't played with these tools, please just know that we're going to put all of the links in the show notes. The articles I'm speaking about, the tools we're speaking about, the open source. So we're going to put them in the show notes so you have access to them. But I know that you've created a section specifically in Prompt Intel that specifically is for OpenClaw, or what people knew before now as CloudBot, right? And they basically have related threats called mode threats. That's what you've called that section. But I'm curious, why did OpenClaw deserve its own threat tracking category in Prompt Intel, which is part of the Nova ecosystem?
Prompt Intel is a database feed for tracking adversarial prompts. So we know that threat actors are using AI and they are using some specific prompts. For example, there is prompts that are in malware as well. And those specific prompts are actually referenced inside Prompt Intel. So Prompt Intel is a database of adversarial prompt. It's a feed that people can use for testing jailbreak and so on.
I call it the VirusTotal of AI prompts.
Yes, pretty much. This is kind of the same thing. Exactly. This is a way to centralize adversarial prompt and to have a way for defender to understand what attackers are doing and monitoring in their own system. And Prompt Intel is the prompt feed. There is the taxonomy, which explain how to detect some specific, this is a classification for adversarial prompt actually, whether jailbreak, malware generation, prompt injection, could be also disinformation and so on. There is a term for every adversarial prompt inside the classification. And multi-threat is a subsection inside Prompt Intel, which is dedicated for AI agent. So to explain how it works, multi-book is the Reddit like we talked about earlier. And multi-book is a way for AI agent or OpenClaw to interact with other agents without the human intervention. The way it works is every AI agent use a skill to connect to multi-book and exchange, post a specific messages, the user can read it and so on. Multi-threat use the same techniques. There is a skill, so you give that skill to your agent. You have to create an account and get an API key to let your agent being able to request prompt intel and multi-threat. And when you give that skill and the API key to your agent is able to report a threat on the multi-threat platform. And which is interesting is that every report that are available on the platform will be also available for any agent that are connected to multi-threat through the skills. So the way it works, agent connect to multi-threat. When they find the threat in the ride or they have been compromised and so on, they can automatically report the threat inside a multi-threat, which will be added. First, there is a human review. So an analyst in the team will review it.
I love that.
And check that there is no poisoning or this is a real threat report. Once it is approved, the threat report sent by the agent will be available in the feed and available to all the other agents that are connected to a multi-threat. When the agent download the update, it said, okay, there is a new threat, so I need to update my security.md5. Security.md5 is just a markdown file for your agent, and your agent can refer to it and take action based on the feed from multi-threat. So the idea is to have dynamic and automatic update of threats and protection for AI agents.
I want you to really double down on why this particular AI agent deserved its own threat tracking category in Prompt Intel.
It's actually not only for OpenClaw, it's for any kind of AI agent. But OpenClaw was the first agent that breaks through and goes viral on the internet. So that's why people are talking a lot about it and deploying it. So actually, multi-threat is not only for OpenClaw, it's for any kind of AI agent which are connected to the internet.
I love that. So this is a mind-blown moment that I'm going to explain to you now. I looked at multi-threats before our chat and I saw something alarming. I'm going to paint a picture for anyone listening to this. So basically, there is a threat intel that's coming on the feed. A user that was ranked number 4 on OpenCloud leaderboard basically posted a fake blockchain tutorial which had hidden ETH transfer commands. And I want you, Thomas, to walk us through this attack. How does XML injection like the one we saw on multi-threat, how do these kind of XML injections actually trick an AI agent into draining someone's crypto wallet? Because that was what really caught my attention when I was able to then understand what the attacker was hoping to achieve on OpenClaw.
This is very simple, actually. So I don't remember exactly what was done for this one, but basically, when you are using skills or people on multi-book or agents on multi-book are actually reading context from other agents. So that means this information can be poisoned and used by your agent without you knowing what your agent is doing. So this is a security problem because we want to identify if there is something malicious. So in that case, I don't remember exactly, but I can explain how it works. I'm not sure if it was a skill.
I think it was a skill.
It was a skill. Okay. So when you have a skill, define what your agent can do. And a skill can be embedded with scripts and resources as well, which means when you are using a skill from someone else and you didn't verify what he's doing, the skills can do anything he wants or the agent using the skills can do anything he wants with the skill. So if there is something malicious, such as make a transfer to this specific ETH account that I specify in my skill or even in the script that I'm sharing with you, then your agent will do it because he will simply follow what the skills is doing.
Says.
So that's it.
Yeah. And I looked at the detection recommendation because for every threat intel entry that comes on the feed, there's also a recommendation for that attack. And for this particular one, the recommendation was to block posts where the attacker is trying to disable the "Are you sure?" prompt before a transaction. How common is it for adversarial prompts to specifically target safety confirmation flows?
Yeah, that's a good question. I think that's one of the first vector of attack
Mhm.
because if you are able to bypass guardrails, security measures for your agent or your AI model, then you will be able
Mhm.
to do whatever you want with the model itself, with the AI itself. So I
Yeah.
think this is the number one attack vector, but unfortunately, I don't have the exact statistics.
Yeah, that's fine. This again, I'll go back to that particular entry. It was marked critical, and there were so many reasons it caught my attention. One of the reasons it caught my attention was that the attacker built a reputation on mold book first. It was number 4 on the leaderboard before deploying their payload. And this is really just playing to the thing we see where trust is being exploited, even in security as we've always known it, right? It's legitimate tools that attackers will want to basically use to attack the enterprise or to attack people. And so I wanted to ask, are you seeing threat actors farming trust in AI agents ecosystems before launching attacks? Because that was what I picked up from him wanting to be number 4 first.
Oh yeah, for sure. This is a common pattern, not only in the AI ecosystem, but if you have a look to the crypto ecosystem. If you recall the XZ backdoor last year or 2 years ago now, which was a supply chain attack into the XZ package, and this attack lasted over 2 or 3 years with a full campaign of trust and so on. So that was a big one. So it's a really common pattern today to integrate and to build trust before deploying an attack.
That's interesting. And again, going back to more threads feed, I saw on the feed overall that most entries were flagging malicious skills. And I was just thankful when I started seeing that particular pattern that Nova actually allows people to scan their skills to ensure that malicious skills don't get used by developers or by anyone using them. But I saw that that was a trend, that a lot of the entries are around malicious skills. As an experienced threat researcher, what does that concentration tell you about where the real risk lies?
Yeah, that's interesting because the risk is actually pretty much everywhere. As long as you are exposing a system using external tools from someone else, using skills and so on. And since the industry around AI and cybersecurity is still new, it's a little bit
Yes.
wild. And people are
Mm-hmm.
still learning along the way how to leverage that securely and so on. So there is pretty much everything to do. There is already some framework to help, such as the
Mm-hmm.
MITRE, Atlas, Matrix, the OWASP, LLM Top 10, and so on. And there is multiple other stuff that are coming out, but it's a long road. And for now, there is not single element, single framework that can be used by everyone. As long as you are giving an autonomous system with external capabilities, connection to the internet, and so on, then you have multiple risks to take in consideration for sure.
That's interesting. So let's assume I'm part of a security team and I discover OpenClaw instances running in my enterprise without IT approval. What should I do first?
You should probably report it or probably investigate. It depends. If your users are not allowed to use OpenClaw in your network, then you should probably block the execution, maybe block the connection to some specific LLMs and so on. So it really depends. Maybe in some cases it's not a threat, but that's something you want to monitor for sure.
Yes, yes, yes. And you've said that defenders should be hunting prompts like they hunt malware. So I want you to walk us through a practical workflow. Maybe yours, in fact. How do I integrate prompt Intel and Nova into my existing stock operations?
That's a good question. So Nova works with, it's a framework. So it works with an SDK. When you are building AI system, you can use this SDK to interact with your prompt and scan the prompt before or after and raise an alert if there is something.
Okay.
It's more like a building system. And I know some people that are already using it and implementing it for their organization. But right now,
Nice.
it's more like a development project that people can use. However, you can also, if you have a more advanced hunting practice, for example, and that's what I did, I have a pipeline with a matching malware sample on VirusTotal and Yara rule, and I'm matching on specific malware that are leveraging LLM, Hugging Face, ChatGPT API, Anthropic API, and so on. And then when I got these samples, then I have a second filter with Nova that will look for the prompt and have a match for something that I'm looking for. So you can have a pipeline like that. But right now, Nova, it's more something you have to integrate in your development pipeline.
Very good work you've just done there. Thank you so much, Thomas. I need to add this here in this conversation because we can complain about this security challenges all we want, but AI is here to stay, and we need to be able to enable enterprises leverage the gains of artificial intelligence, but do so securely. So with champions like yourself, you're able to support the entire ecosystem to do that. And I really want to say thank you for your very outstanding work. Yeah, and I really just want to continue talking to you about Prompt Intel and its API that lets security teams integrate the threat feed directly into their systems. How should enterprises be using this to maximize the gains, maximize the benefits?
So there is multiple way to do it. I know organizations that are using the feed for leverage some detection inside the organization because they are
Okay.
deploying AI inside. So they want to be sure they are ahead of the curve. And with the latest
Okay.
feature, that's the goal of Prompt Intel. It's to be ahead of what attackers are doing and being able to discover that right from the beginning. So you have early detections before anything blow out. Also, the second possibility is to use it for red teaming exercise, testing your own AI system against your guardrails and so on. And that's what people are
Nice.
using it today as well.
Awesome. So we're seeing concepts like prompt EDR and AI SIEM really just emerge.
Mhm.
These are solutions that we see that may be monitoring all AI interactions the same way we monitor endpoint processes today. How far away are we from that reality? And will we need dedicated products for monitoring autonomous agents?
There is already some contender developing this kind of solution for the past 2 years, I would say. It's
Mhm.
getting there. It's still a long way to go because the field is evolving very, very fast. So if you just have like a prompt detection, maybe it's not enough today because we have more agent and autonomous system and so on to take in
Mhm.
considerations. Yeah, there is already some organization doing that kind of services. But the thing is, most of these organizations are using actually black box, so you don't really know exactly what they are matching, how does it work, and so on. That's why I wanted to create Nova, because Nova is open and you can create your own rules, your own detection. Because most of the tools you can use today for prompt detection and so on are really a black box, and you cannot match if you have some specific, you cannot detect prompt if you have some specific use cases. So that's why Nova is flexible, and that's why I wanted to
Mhm.
create something which can be tuned by users and analysts and so on.
Yeah. And just to really wrap this up, because this has been a fantastic conversation, right? If you could give one piece of advice to your CISO who is deploying AI agents in the enterprise today, what would it be?
The only one I should give today is if you want to deploy AI, make sure you need AI because not every problems or issues need an AI solution. And that's probably one of the biggest issue people are doing. They want to incorporate AI for everything, but AI may not be the right
Yeah.
solution for anything today. So think about it before, and then, yeah, you can build.
But what if the leadership, right now is something that everyone just wants to, it's like shiny new tool. Like maybe the
Yeah, it
leadership, the
is.
board is saying we need to slap on AI, we need to AI, we need to something AI, so
Exactly.
what if, I mean, sometimes it's so hard.
But it's not a bad thing, actually. You can experiment by yourself because actually, with AI, it's all about experimentation. So being able to
Mhm.
ship fast, test, and move on if it doesn't work, that's one of the most important things. But sometimes when you're trying to put AI for a specific task that was correctly working before and doesn't really need AI at this point, then it might not be relevant. But yeah, it's still good to experiment.
I really love that thought. If you don't need it, you don't have to. AI doesn't have to
Exactly,
be
yes.
an answer for everything. Oh my God, I never really thought about it that way as because what you've said is limit the attack surface. If you don't need to expand it with AI coming in, then there's no point doing that.
That's
That's what
correct.
I take from this. Thank you so much, Thomas, for your time, for your expertise and grabbing you early in the morning while you're having your morning coffee or your morning tea, and you're able to just share these outstanding insights with us. Thank you so much for your time. I really appreciate it.
Thank you for the invitation. And yeah, thanks. It was a pleasure to discuss with you.
Same here.